in our Saxon Course 3 book, and we're talking about powers and roots. So, powers and roots are very closely associated, which we will learn about in a minute. But to show repeated multiplication, we use an exponent. And an exponent is a little number that is put above another number. We call this number the base. And this tiny little number up here, we call the exponent. And 5 squared means 5 times 5. So we use the exponent to tell us how many times the base will be multiplied together to give us the answer. So let's look at 5 cubed. 5 cubed has an exponent of 3. So that means that the base 5 will be used 3 times multiplied together. So 5 is a factor 3 times in the answer. So 5 times 5 times 5 is 125 if you multiply it out. The 3 exponent, okay, tells you how many times the base is used as a factor. So how do we read these things? So 5 squared is read 5 squared, 5 cubed, 5 to the 4th power, or we could just say 5 to the 4th. A lot of times you'll hear Miss A say 5 to the 4th. That means 5 raised to the 4th power. Or 5 times 5 times 5 times 5. So we just saw 5 cubed, and 5 cubed was 3 5s multiplied together. This is 4 5s multiplied together. This is example 1. What would 4 5s? 3 5s was 125. So we multiply that by 5, and we're going to get 5 to the 4th, and I'll erase example 1 here. 5 to the 4th is 625. When you multiply it all together, 5 times 5 times 5 times 5. Now, 10s are easy. 10 to the 4th means I'm just going to have a 1 put in front of 4 zeros. Because remember, every time we multiply by 10, we just add a 0. So a 1 and then 1, 2, 3, 4 zeros, put our comma in, and 10 to the 4th is 10,000. So here we have example 2. Write the prime factorization of 72 using exponents. Okay, so I didn't have room to do it that way, so I wrote my 72 this way. So let's do the prime factorization. 72 will divide by 2, which leaves me with 36, which it's easiest to divide by 3, which is also a prime number. 3 into 36 is 12. So now I'm going to divide 12 by 2 and get 6. And 2 times 3 gives me all of my factors. Now, in your book, they like to do this up. I don't like to do it up. I like to do it down. But, use whatever works for you, as long as you're getting the prime factorization right. So if we look at this, we have 1, 2, 3 2's. So we could write that as 2 cubed times, there are 2 3's. So 3 squared. Okay, so it is not incorrect to say 2 to the 3rd power. It is not incorrect to say 3 to the 2nd power. It's just usually for squares and cubes, we say 2 cubed, 3 squared. So example 3 says, the figure shows a square floor tile that is 1 foot on each side. Find the area covered by the tile in square inches using the formula area equals side times side. Okay, so here is example 3 and my cute little picture of a square tile that is 1 foot by 1 foot. Okay, so find the area in square inches. Now, 1 foot, we're not told to find the area in square feet. We're told to find the area in square inches. So what we're going to do is, instead of 1 foot, we're going to change that to 12 inches because we know that 12 inches is equal to a foot. Okay, so 12 inches times 12 inches would be 12 inches squared. So here, area is side times side. 12 inches times 12 inches is 12 inches squared. So now we know that that's going to be 12 squared inches squared, or square inches. So 12 squared is 144 square inches. And then we have example 4. And it says express all of this with exponents. Okay, so we have a constant in the front. We call that a coefficient when a constant is in the front. So we have 2 times x is x squared times y cubed times z. Now, when we're writing an expression with exponents, we do not need to have these times in here. So we would just write 2x squared y cubed z as our final answer. So now we're going to learn a little bit about the inverse of the power, which is the root. Okay, so here we have a little note. Say just burned my fingers, so I'm having to do everything kind of different. Okay, so the inverse of raising a number to a power is taking a root of a number. When we mean to take a root, we use this sign, which is called the radical sign, and it indicates the root. So then we have how we read square root. So this is the square root of 25, and understood right here in the square root is a little bitty 2. Now we don't write that because when we don't have a little bitty 2 there, it means square root, which is the number that when squared will give us 25. So you notice that the square root of 25 is 5 because 5 squared is 25. So we would read this, the square root of 25 is 5. Down here, we have a little tiny 3 that is right here. We call that the index. And so this is the cubed root of 125 is 5, because 5 times 5 times 5 is 125. So 5 cubed is 125. The cubic root of 125 is 5. So they do and undo each other. The cubic root, cube root or cubic root, either one is fine. The cube root of 125 is 5. So that's how we would read that. And we call the number that is underneath the radical sign the radicand. Okay, so we have this number that's in the little hook here. It's called the index, and the radicand is underneath the radical sign, and this whole thing is called the radical sign or the radical, okay? And the whole thing would be the radical. Okay, so index, and the fifth root of 32 is 2, because 2 to the fifth is 32. Okay, so here's example 5, and we're taking the square root of 144. Now I know it's a square root because there's nothing there, and anytime there's nothing in the little hook, we know that it's a square root because that's always the default or the understood root. So the square root of 144, if you know your multiplication facts, is 12, because 12 times 12 is 144. So we're going to say 12. And if we wanted to justify that, we would say 12 squared is 144. So we could say because 12 squared is 144. Okay, so the cubic root of 27 is 3, because 3 cubed is 27. So 3 times 3 times 3 is 27. So the cubic root of 27 is 3. Okay, so now we're defining a term called the perfect square. Okay, a perfect square is the square of a counting number. 25 is a perfect square. 64 is a perfect square and a perfect cube. So here we have, okay, 5 times 5 is 5 squared is 25. Therefore, 25 is a perfect square. Okay, I just made up that, it's not an acronym, just perfect square, because I'm out of room on my board. Okay, 8 times 8 is 64. So 64 is a perfect square. However, 4 times 4 times 4 is also equal to 64. So 64 is also a perfect cube. So 64 is both a perfect square and a perfect cube. All right, so here is example 6. And example 6 says the floor, I dropped my book. The floor of a square room is covered with square foot floor tiles. If 100 tiles cover the floor, how long is each side of the room? Okay, so we know that the room is square. I can't move much because of this thing, so I'm kind of awkward. All right, so 1 foot by 1 foot is each tile. And the area of the room is 100 square feet. So there are 100, remember this tile is 1 square foot because it's 1 foot times 1 foot is 1 square foot. So there are 100 tiles on this square floor. So we're trying to find out how long is each side. Since we know that it's square, then we know that something squared is 100. Okay, so hopefully you know what that is, but the way that we would denote that is the square root of 100 is what? Okay, and hopefully you know the answer is 10 because 10 times 10 is 100. The square root of 100 is 10. So we would say that each side of this room was 10 feet long. Okay, so that is the work for example 6. And example 7 says, all right, let me read it. It says, name the first 3 counting numbers that are perfect squares, then find their positive square roots. Okay, so we're looking for perfect squares. So what is 1 squared? 1 squared is 1. So isn't 1 a perfect square? So 1 is the first perfect square, and its square root is 1. Square root is 1. Okay, so then I go to the next number, 2. 2 is not a perfect square, but what is 2 when I square it? 2 squared is 4. So the perfect square is 4. The square root of 4 is 2 because 2 squared is 4. Okay, and then I go to 3. 3 is not a perfect square, but 3 times 3 is 9. And 9 would be a perfect square because 3 is the square root and 3 times 3 is 9. So this is the square root column. And these are your first 3 perfect squares, 1, 4, 9. What would the next one be? Okay, we did 1 squared, 2 squared, 3 squared, 4 squared would be 16. So if we were told to get the first 4 perfect squares, the next one would be 16. The next one after that would be 5 squared, which is 25. Hopefully you get the pattern. And now make sure you have your packets open because we're going to do practice A and B. Okay, so 10 to the 5th, we simplify, is 10 times 10 times 10 times 10 times 10. Remember that 10 is the base, and it will be a factor of the answer 5 times. Okay, so remember anytime we multiply 10s together, we're just going to tack on a 0 for each 10. So 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. 1, 2, 3, comma. 100,000 is 10 to the 5th power. 3 to the 4th power will be 3 times 3 times 3 times 3. Well, the easy way to do this is 9 times 9. 9 times 9 is 81. So 3 to the 4th power is 81. And 81 would be a perfect 4th power, wouldn't it? So we're doing C and D of your practice set. We have 15 centimeters squared, which just means 15 centimeters times 15 centimeters. Okay, well, centimeters times centimeters gives us square centimeters. So our answer will be in square centimeters. Okay, and 15 times 15, 5 times 5 is 25. 1 times 5 is 5 plus 2 is 7. And then 15 goes right there. So 225. 225 square centimeters is 15 centimeters squared. Oh, this is a nice day. The rain is just pouring outside. We got a snuggly baby inside. Oh, this is fine. So square root of 121 is 11, because if you know your multiplication facts, you know that 11 squared, or 11 times 11, is 121. So the square root of 121 is 11. All right, so now, remember when we're doing a cubic root, we're looking for the number that when multiplied by itself is 3 times is going to give us 8. So that's going to be 2 times 2 times 2. 2 times 2 times 2 is 8. Therefore, 2 cubed is 8. And the cubic root of 8 is 2. Okay? So now, the square root, remember there's nothing there, so that's the square root. And the square completely undo each other. So the square root of 5 squared is 5. Because that square and that square root just cancel each other out, and we get 5. And you can see it. 5 squared is 25. The square root of 25 is 5. All right, so now we're working with simplifying using exponents. So 5x, y, z is going to be 5x, y cubed, z squared. Okay, 5xy cubed z squared. And remember, when our variables are stacked real close like that with no sign, it always means multiplication. And here we have a, so that would be a cubed b. And that's all there is to it. Okay, so here we are on letter I. We are going to simplify this. We have 3, and we have 1, 2, 3 x's, so that's x cubed, y squared, and that's all there is to that one. Okay, now Jay says, Mr. Chen wants to cover the floor of his garage with a non-slip coating. His garage measures 20 feet on each side. Use the formula A equals S squared to find the number of square feet of floor that need to be coated. Okay, so here's the picture of Mr. Chen's garage. It is 20 feet by 20 feet, and we're going to multiply them together or square them. So 20 feet squared would be 20 times 20, which would be 400 square feet of area that needs to be coated with this coating. Now we're starting our written homework, number 1. Okay, and number 1 says, at the baseball game, 40% of the fans joined in singing the national anthem, while the rest listened quietly. If there were 25,000 fans in the stadium, how many joined in the singing? Okay, so here we have 40% of the fans sang, and 25,000 fans altogether. How many sang? So we're doing a 40% of 25,000. Okay, so we have 40% of 25,000, 40% of 25,000. Remember, your of is times. So now let's just make this a little bit easier. Let's take our 100, which has 2 zeros, and cancel off the 2 zeros on the 25,000. So now we have 40 times 250. Well, let's just look at the 4 times the 25. We know that 4 times 25 is 100. And then we're going to tack on 2 zeros. So there's 100. Tack on the 2 zeros. And we had 10,000 people singing the national anthem. Okay, so now we're on number 2. It says a gallon of milk contains 128 ounces. How many 8-ounce cups can be filled with a gallon of milk? Well, they did most of the work for us, didn't they? 128 ounces is a gallon, so that's what we have to work with. And we're looking for 8-ounce cups. So aren't we just going to divide 128 by 8? So that's pretty simple. But let's do it using our conversion factors. So we're going to start with 128 ounces times 1 cup is 8 ounces. Okay, so remember, ounces cancels ounces. We're left with cups, which is what we're trying to find. So that is the actually most correct way to do this. Instead of just deciding to divide, we match up the units with a conversion factor here. So this is the way that you're going to see it done in the examples of your book. Okay, so it shows us that 128 needs to be divided by 8 because 8's in the denominator. So let's do that. 128 divided by 8. 8 goes into 12 one time, then 8, leaving a 4, and an 8 gives you a 6. So 16 glasses will come from that gallon of milk. 16 8-ounce glasses. All right, so number 3 says, Jackie played the drums in the band. If he beat the drum at a rate of 110 beats per minute, how many beats would he play in 4.5 minutes? Okay, so we can do this in our head, or we can do this using multiplication. But what we're going to do is we're going to say, I'm going to do it with 4.5. So remember that 4, I'm going to do it this way. 4 plus 1/2 is the same thing as 4.5, isn't it? So I'm going to multiply 110 by 4.5, okay? And I'm going to distribute that across. So 110 times 4 is 440 plus 110 times 1/2. Half of 110 is 55. So what is 440 plus 55 is 495. He's going to beat that drum 495 times during 4.5 minutes. Okay? Number 4, 5, and 6, and we will be done with this lesson. Okay, number 4 says 4 inches cubed, which means 4 inches times 4 inches times 4 inches. We talked about earlier that 4 times 4 times 4 is 64. Okay, so we have 64 inches times inches times inches is inches cubed. Pretty simple. All right, the cubic root of 1. What number, when multiplied by itself 3 times, gives us 1? The answer is 1, because 1 times 1 times 1 is 1. In fact, 1 to any power is still 1. Okay, so the cubic root of 1 is 1. And the square root and the square undo each other, so the answer is 8. Now remember, 8 squared is 64, and the square root of 64 is 8. And we have done all of your practice. We have done every example, and we have done the first 6 problems in your lesson. So now it's time for you to go do the rest of your lesson. This is Mrs. A, and may God bless your day.